So now that we've talked about stress and strain, let's go ahead and build on that and talk about one more concept, which we actually talked about at the beginning of the 9 weeks, which is called modulus of elasticity. Let's go ahead and define it for ourselves. We've defined it before, but it is the ability of some material to resist stretching from a force. To resist stretching, or deformation, I should say. So we can write that in. Deformation, in parentheses if you want to. Move this over a little bit. From a force, and there's another way we can write it. It's stiffness. Now, we talked about this at the beginning of the semester when we compared it to inertia. Remember, inertia is based on shape. Elasticity is based on the material we used. In other words, elasticity is an inherent property of a material. You make a material thicker, you do not change its elasticity. It might be stiffer, but it's stiffer because of the inertia, not because of the elasticity. Makes sense? Of a material. The last thing I want to point out is it is a ratio. Or you could look at it as a slope when we put it in our graph forms, right? A slope, rise over run. In this case, our stress would be rise, and our strain would be our run. Stress to strain. And with that, we've kind of already given the formula for elasticity that we'll be using, if you look at it a certain way. But basically, elasticity equals stress divided by strain. So, if we look at member AD, go back to that same member we've been calculating this entire lesson, what did we get for our stress on member AD? For the stress. 711, very good, PSI. And what do we get for our strain? It's right there, guys. 0.0, very good. 021, and then no units, which is important to recognize. So if we plug this into our formula for elasticity, we would say, well, E equals stress over strain, which is 711 psi, divided by 0.0021. And if you plug this into your calculator, you'll get about 339,000. And what would be our units? PSI. And let's go ahead and point out that this is to a precision of 1,000. We rounded to the nearest 1,000. If we plug this into our calculator, you will not, I don't think you get exactly 339,000. And I want to point this out to you guys to compare it to your strain. As we said earlier, strain is always a really small number, or usually, I should say, usually a really small number. You can expect elasticity, E, is usually a really big number. So if you get an elasticity of 7, you're probably off. If you get an elasticity of 0.2, you're probably off. You should expect a number in the thousands. A big number. And now's a good time to tape in your formula sheet, which I took the liberty to modify just a little bit. I added in that F is force, that is true, but P could also be a variable for force. Assume F equals P, which would be very important for you when you guys work on your activity tomorrow. When you're calculating your shear stress, you could use P for force or F for force. And then if you look, there are actually multiple equations for elasticity, although if you think about it, they're really all the same formula. But we'll talk about that more in tonight's notes.